All right, welcome. In the high-stakes world of business, some companies just take off like a rocket, while others, well, they can suddenly collapse. For decades, trying to predict who's going to fail has been one of the biggest challenges in finance. But what if a new kind of intelligence could see the future a little more clearly than we can? So, can we really do that? Can we teach a machine to see disaster coming? Well, that's the exact question a fascinating research paper from 2023 by Mira Aranya and Kartikeya Bowler dives into. They tackle this problem head-on, and trust me, their findings could totally change how we think about financial risk.
Now, to really get why this new research is such a big deal, you have to understand that this is not a new problem, not at all. In fact, people have been trying to build some kind of financial crystal ball for pretty much 100 years.
This whole journey kicks off way back in the 1930s with some pretty simple comparisons of financial numbers. Then, in 1968, things got a huge boost with the famous Altman Z-score. It's a formula people still talk about today. The 80s brought in even more advanced stats. But here's the catch. Every single one of these models, built on looking at the past, had a major weakness: the totally unexpected.
And that right there is the single biggest challenge for any prediction model. Those massive, unpredictable events that just rewrite all the rules. You've probably heard of them. They're called black swan events. The paper's authors, Aranya and Bolar, they just nail it with this quote. "We live in a VUCA world that's volatile, uncertain, complex, and ambiguous." And when they talk about fat or tails, what they're really saying is that these crazy, out-of-nowhere events are actually way more common than the old models ever thought. So when a true black swan, like the COVID-19 pandemic, hits, all those old assumptions get blown out of the water, and the models can fail big time.
Okay, so this is where Mira Aranya and Kartikeya Bowler come in with a really brilliant two-part solution. See, they didn't just want to build a better model. They wanted to build a model that could actually handle the chaos of the real world.
They broke their whole research down into two really clear, testable ideas. First, let's prove that AI is just flat out better at this job than the old statistical methods. And second, and this is the cool part, let's see if we can actually teach that AI to understand and account for a massive, unpredictable shock.
And this is where their thinking gets really clever. How do you measure the impact of a global pandemic on a company's books? Well, they realized that during the lockdown, for the first time in forever, a lot of companies' operating costs actually went down. Why? Because factories were shut, business just stopped. By tracking this super unusual dip, they created a number, a proxy, that represented the chaos of a lockdown.
Okay, so they've got their hypotheses, they've got this clever new variable. What's next? Well, Aranya and Bolar set up a head-to-head competition. You can think of it like a financial prediction showdown, pitting the old-school methods against the new, artificially intelligent challengers.
And the key thing to get here is how these two teams think so differently. On one side, you have logistic regression. It's reliable, but it's rigid. It's like a checklist. On the other side, you've got neural networks and random forest. These are AI models that don't just follow the rules. They're more like detectives, learning and uncovering complex hidden patterns in the data all by themselves.
And look, this was not some small-time experiment. They threw a ton of information at these models. 12 years of financial data, covering 63 different financial ratios for over 1,000 companies in India. The goal was simple, a direct challenge. Tell us which of these companies are going to fail.
So the stage is set. This brings us to the moment of truth, the results of that first big test. Which type of model is fundamentally more accurate? Is the old way good enough, or does AI really have the edge?
And the results? Well, they weren't even close. The traditional method, logistic regression, it was right about 66% of the time. Not bad. But the AI models, especially random forest, they jumped all the way up to over 75% accuracy. That is a massive leap in predictive power. It completely confirmed their first hypothesis. AI is just better at this.
Okay, so that settles it. AI is the winner. But that leads to their second, and you could argue, the more important question. They had the best model, but could they make it even smarter by teaching it what a real crisis looks like?
And the answer was yes, it did. Now, you might look at that table and think, hey, that's a pretty small bump in accuracy. And you're right, it's subtle. But what it proved was powerful. By adding that one single variable representing the chaos of COVID, the best model got even better. It proved their second hypothesis. You absolutely can make an AI more resilient by teaching it to account for chaos.
So after all that, all the data, the models, the showdown, what's the big takeaway from the work of Mira Aranya and Kartikeya Bolar? Why should you, or any investor, or lender, or business owner out there, really care about this?
Well, takeaway number one is pretty simple. The evidence is in. The future of analyzing financial risk belongs to these more sophisticated, more adaptive AI technologies. They can see patterns and pick up on early warning signs that the older, more rigid formulas are just blind to.
But the second takeaway, this is the real game changer. The true genius here isn't just about using a smarter algorithm. It's the idea of actually quantifying the unquantifiable, of turning a crazy black swan event into a piece of data that the AI can learn from. This is how we start to build predictive systems that don't just fall apart when the world gets messy.
You know, this research really just cracks open a door to some incredible possibilities. Today, it's about predicting which companies might go bankrupt. But this whole approach, teaching an AI to understand uncertainty, you could apply that to supply chain disruptions, to climate events, maybe even to public health crises. The question isn't really if AI can predict the future anymore. The real question is, what part of the future should we ask it to look at next?